Welcome, Matt. Thanks so much for coming in to this retrofit in progress. Yeah, looking forward to showing you around. Come on in, watch your head. What was a really interesting part of this was the preparation of getting it right. You know, the boring stuff, some people would say, the electrics, the plumbing, the space. And what we decided to do was, with our electrics and all of our plumbing, was bring it all out to the garage, give ourselves a bit more space inside. Right up here, we've got a new fuse board. So it's all set up for the future, ready to go for what we've already done in the house. So as you can see, we know everything is from the housing side of the electrics, and then what we've already done on the renewables. So kind of like having two separate boards. We've also got a individual kilowatt hour generation meter, purely just for the heat pump. Gathers a little bit more data and also just assures you how much heating and hot water you're using. So super handy to know. And then in the future, we'll probably have solar battery data and, an EV charge point or two if everything goes well. So the plan was to make this a little bit of a showroom, I guess. I bring a lot of people here. The people I work with, I actually offer to come along. And essentially everything is here. Everything is out of the building. When we purchased this property, everything was inside. You know, it was blocking up the bathroom, taking up space. And if you have the fortune that you're able to do this, then chuck it all out into one space. So now every year when the engineers come in for the service, you can walk in the garage door, crack on, see everything in one spot and get to work. See, it's a really simple design. The hot water cylinder is oversized, as you can probably see. It's a 3-bedroom bungalow. It's about 90 square meters. And this is a 250 litre hot water cylinder, which you could argue is comfortable for a 4, 5, 6-bedroom house. But the plan is eventually to go up into the loft, add 2 more bedrooms, potentially even 3, if sizing allows, and therefore we're future-proofed hot water-wise for then. Another component that's key in a heat pump install is keeping the system clean. We've got a MagnaClean based in here, or it's actually easy to isolate for the engineers, or you can do it yourself, but it's part of the annual service. Again, super easy to get to, so good design by the installers. This other tank here, which you don't see on every heat pump install, is called a volumizer. And essentially it's like having a massive radiator just sitting out here. And the reason we chose to do that was because we've upgraded the house now so that it runs very efficiently and at a low flow temperature. But in the future, we might actually have to pull a few of them radiators out. And what will happen then is the system water volume will be lowered. So the idea is that when you have an extra chunk of volume here, which the heat pump needs to run efficiently, it's already here, it's already future-proofed, and actually we probably have too much system water volume as it is. But the idea is that in 4 or 5, 10 years time, we've got this additional bit of hot water here and we're future-proofed. I've also put in a little brain into the system. So this is a heat pump optimizer called a Homely. And what it does is it takes away all the stuff that we don't want to be worrying about. You know, heat pumps need a lot of tweaking. Heat pumps need optimization. A lot of people talk about the weather compensation curve. This is a little brain that just does it all for you. It's in your pocket. You adjust it, you talk to it, and it does all of the smart work in the background that, you know, the average homeowner doesn't need to really worry about. So we've gone for that as well. Also put the controller out here in the garage, which tells us in real time exactly what's happening with the flow temperatures, what the delta T of the system is, how hot the cylinder is, what temperature it is outside. So this morning I came out here, it was 2 degrees. The heat pump was defrosting, it was completely frozen over, and the delta T of the system went up to about 10 degrees. So 10-degree difference between the flow and the return. And as you can see right now, to keep the whole house inside at 19, we need 35-degree flow temperature. So on the return then it's coming back about 6 degrees, 5-6 degrees cooler, which is really what we want to see max. So super handy to have the controller in one place, hot water cylinder, any of the additional, parts of a project that you need when installing a heat pump, all in the one place. So really happy we went about it this way. So as you can see here on the controller, it tells you that it's Wi-Fi connected, the temperature outside, and what the difference is between the flow and the return, which is really handy. Last night you can see the hot water cylinder was recovered up to 65 degrees for its Legionnaire cycle. We've done a few sets of dishes today and it's dropped a couple of degrees to 57. I really like to come out here every now and again and just check that the system's COP is getting recorded. So with this particular controller, it's super easy. You can just go into the data and find out the total amount of energy the heat pump has consumed. Yeah, so as you can see, this is the total amount of energy that the heat pump has consumed so far, what it's produced overall, and the COP, of course, as well. So super easy to go through on the heating side. Coming across then to the hot water side, you can also do the same. So this is the lifetime hot water use of the heat pump with a pretty decent COP of over 3. I'm happy about that. But if you like, you can come out any day or even any week and you can see exactly what the heat pump has produced. Cool. Yeah. Yeah, this house is officially gas free. First thing we did when we moved in was take a big chunk of pipe out that was leading to the boiler and got the gas meter guy out, literally cut the cord and thankfully, yeah, no more gas. Before we got here, it was a jungle. So yeah, we dug it all out and I put in the heat pump base myself to help the guys out a little bit. This is a 6 kilowatt Midea Arctic R290 unit. So it's got the new refrigerant in it, the one that most heat pumps are using. Aesthetically, looks pretty good, I think. You know, most of them are this color now. So it's slightly undersized at the moment in terms of its design. It's actually pushing the top end of what this heat pump is designed to do. But we did that on purpose because in the future, we're going to be adding maybe double the amount of floor area plus 2 additional bedrooms as well. So this heat pump will eventually be oversized, would you believe, for when that occurs. So it's definitely been interesting thinking about the design of where the property is now and where it's going to be in 5 to 10 years time. But thankfully with this unit, we're future-proofed anyway. So one of the other reasons we went for this property was the roof. I've done a preliminary design and it looks like it can take 38 solar panels eventually. So it's got a decent pitch. That is directly south facing, so it's an east-west split. So we'll get a lot of evening solar gain eventually, but I'm looking forward in the future to standing here, looking at the heat pump, looking at the solar system and, you know, maybe some battery storage. So that's the plan for the future, yeah. Cool. So yeah, a little bit of a quirky detail put in here, which I'm not sure how it's going to go yet. It's a future experiment, but essentially a heat pump condensate can actually produce a lot of usable water. So what I've done here is I've ran the condensate out to a water butt I picked up from the dump and I'm collecting rainwater. I'm collecting condensate water from the heat pump. So as well as collecting rainwater from the house, we're also collecting water out of the heat pump. And eventually, I hope to put some hanging baskets in here and yeah, simply put the water into the hanging baskets for the flowers. So a little bit of future experiment. I'll post some data in time to come about, you know, was it actually worthwhile? Is it a bit of a gimmick? Or, you know, is it something that maybe other heat pump installs can do? So I'll let you know how it goes. Brilliant. Yes, yeah, so look, every house needs a plan, a project plan, and essentially we just got a bit of chalk paint, put it on the wall, and this is where we come back to weekly. We draw up what needs to be done, and yeah, literally exit off as we go along. The most interesting one here has probably been 2 weeks ago or 3 weeks ago when the storm came in, fence blew down, fixed fence had to go in. So yeah, it took away from the exciting parts of renovation and it just helps to have a small list, tick it off one by one and you know, get a sense of achievement when you're doing a renovation or a retrofit because it's tiring work. Yeah, so one of the things we chose to do initially was to upgrade all of these guys. We've gone for pretty decent sized radiators initially. The whole system is designed at -2 for 45-degree flow temp, which essentially means when it's quite cold outside, it's snowing, the highest the temperature will actually get out of the heat pump is designed to be 45 degrees. It's been -3, even -4 here a few weeks ago, and the flow temperature got to 41 high. So thankfully, it appears to be working and Probably a little bit underestimated, but that's always nice to be on, a lower flow temperature than originally designed. So yeah, they're pretty big, but when you look at your monthly bill, you really don't mind in the long run. Cool. Yeah, so essentially we're inside now, and unlike older thermostats where it might be a big old wheel or so, this is our little device. As tech has moved on, it's super simple, but the location of this is key. This is essentially talking about the temperature of the whole house. If you go for an open loop design, everything everywhere is pretty much the same temperature. So actually the location of this is really key. We're here in the tiny, well underlit hall, and we've chosen to have our temperature today just in the high 19s, and it's just slightly over at the moment, 20 degree temperature. But again, the key is the location of this little thermostat. Talking to the heat pump outside is key for kind of ensuring that the whole house is an even temperature. Yeah, so temperature outside, temperature inside is all communicated through this little node here. Super easy to set up, took the installer maybe 15 minutes, connected it to the phone and the Wi-Fi, and now all of the internal temperature talks to the outside temperature sensors, and it's simple to control on my phone. Yeah, so I'll send you a picture or two maybe, but this is where the old cylinder cupboard used to be. As you can see, it was cut out. And the pipework was adjusted. So there was towel cupboard here, decent sized cylinder raised up high, and of course all of the electrics as well. So first thing we did was take it all out of here, get it to the skip essentially, and shift all the new stuff and connecting pipework out to the garage. This house is a work in progress.